If you work with AI agents frequently, you've probably heard of the term RAG, or Retrieval-Augmented Generation. Maybe you've even tried to implement it into your chatbots and not seen the results that you expected. Retrieval-Augmented Generation, just to simplify it, is basically you have a chatbot, you have a database, and your chatbot is able to pull information from your database in order to answer your users. But the reality about RAG is the examples that most people cover are just vector databases with no further improvements. And the reality is you have a lot of work to do if you want to make a really good chatbot using RAG techniques. In this video, I'm going to cover 5 different methods of implementing RAG beyond the vector database approach and show you when you should use these in different situations, and even show you an example. The 5th example is how you can combine multiple of these techniques in one single application. Now, I'm not going to dive super deep into every technique. I'll just show you examples and move on. But keep in mind that if you decide to invest in a specific technique, like if you want to do vector-based RAG or if you want to do a graph database, then there are a lot of different optimizations and improvements you can make beyond the first layer that most people talk about. And I'll jump into a couple of examples just so that you know what I'm talking about. Okay, so the first method that I want to talk about is the most obvious one that most people talk about, which is vector databases. So without getting too into the weeds, a vector database is basically a database that allows you to represent text as a series of dimensional numbers. I don't understand the science behind it, but essentially they've been able to figure out the meaning of different sentences and words and how they work together and map them into a multi-dimensional space. We're talking beyond 3 dimensions, oftentimes 1,500 dimensions or 3,000 dimensions. And these numbers represent where that text lies in its meaning, and text that's closer to it in some way on those dimensions is more similar in meaning than text that's further away. So that's the simplified version. But what that actually means is that you can do a search for something based on its meaning. So in a typical search scenario, if you typed in the keyword dog and someone talked about a 4-legged creature that sounds very much like a dog but isn't specifically called a dog, vector search is really powerful because it gets the meaning of the sentence or phrase that the person is typing in and is able to find similar and related information, which means that for a chatbot, you can say, hey, look, this is all of the relevant information we have about what this person is talking about. What people don't understand, though, is it's not a magic wand. There are a lot of different techniques that you can use to make it better, but by default, it's a little bit of a blunt instrument. Okay, so I'm going to give you an example here. I've prepared a very, very simple list of information about the Marvel Cinematic Universe. This is all AI generated, so, for all I know, some of this might be hallucinated, but I think it's pretty accurate. Now, with this information, I want to be able to answer a user's questions about this universe. Now, keep in mind, this is only 3 pages of, tens of thousands, if not hundreds of thousands of pages of information you could have about this universe. So obviously it's not going to know everything, but I want to do a sample because I put in some information specifically around people who have wielded Mjolnir. Oh boy, I'm going to have to say that. The hammer, Thor's hammer. And I want to see if I can get an accurate answer about that through these different methods. Okay, so I'm going to give you a couple of examples of asking questions about this particular part of the Marvel Cinematic Universe. Now, keep in mind, when you're working with an AI chatbot and you're answering questions about something like the Marvel Cinematic Universe, chatbots will often know stuff because of their training data and could pretty accurately respond to these questions. So where you would want to implement RAG is when you're talking about something that the training data is not going to be very accurate on, or if you really need to ground the responses in your company's data or something that's specific to you that the chatbot wouldn't know, and you need to avoid hallucinations. In this instance, some of the answers that I will get are worse than what I would get if I hadn't put RAG into this at all, because I'm not relying on the vast training data of the chatbot. I'm actually just feeding it little snippets from my database. Okay, and that's something you need to keep in mind when you're working with retrieval-augmented generation in general, is that it can be counterproductive if you don't set it up correctly. Okay, now what I am working in here is called N8N. It is a workflow automation tool. It's really powerful. I have it self-hosted on a server for myself, and so I get a lot of automation for like $15 a month. So what I'm going to do is get that document and then insert it into the Supabase vector store that I have set up. I'm just going to show you an example of what that looks like. So what this is doing is splitting up the document into a series of chunks, and those chunks are as long or short as I want to make them based on the settings that I set up. Now I did fairly short chunks, and I also have some overlap between the chunks so that there's a little bit more context. What this allows me to do is do vector embeddings on smaller portions of this document so I can return a small portion to the chatbot that is supposed to be relevant to the question. Okay, so I've inserted that data. Now I'm going to go ahead and do a test chat. So I'm going to say, who wields Mjolnir? I really should have looked up before recording how to pronounce that, because if I get it wrong, there's going to be a lot of unhappy people, but I'll have to deal with that. Okay, so what it's doing here is it's reaching out to the vector store tool, and this tool is basically returning information from Supabase with relevant chunks from my database. Now, what's interesting is the very top one is extremely relevant, right? People who have wielded Mjolnir. This one also says wielder of Mjolnir, artifacts and locations. This one does not mention the hammer at all. So it's interesting that comes up. That's the kind of weird thing that happens with vector search, is that sometimes the results that come through are not what you would expect, especially when this is coming in above this one, which actually mentions the phrase Mjolnir, wield Thor's hammer. So that's where vector search can be really funky and have unexpected results. What you can do to improve this is using a tool called a re-ranker. There are different models that allow you to take large set of results and narrow them down to the most relevant ones. And that is a powerful technique that can improve the results for sure. And that is one of many techniques that you can use. Okay, so the answer here is it has been wielded by Thor, Hela, and Steve Rogers. This is incomplete vision, and at least according to this document, because I think there's more people who have actually wielded it. But in this document, vision is mentioned. I specifically changed the word Mjolnir to hammer because I figured that in the vector embedding model, hammer and Mjolnir might not be semantically that related. Kind of just depends on how the model was done. So it was interesting to see that vision was not brought into, basically I was right, that Mjolnir did not show up as close to hammer. So the unrelated thing about someone's glove is showing up above this chunk about vision wielding it. And it also doesn't say wield. So that's the kind of thing where like you would think that this would be returned, but it's actually not. And that's where things can get tricky. So one way that you can improve this is to return more results and then use a re-ranker and then take the top 10 or so. That's one way that you can do it. Now, keep in mind with the vector store tool here is actually having a chat model respond with an answer based on what was pulled from the vector store. So my agent isn't actually getting the full response from Supabase. It's going and being processed through another model first, which in this case I don't really want to do, but that's just the way this tool was set up. Okay, so you can see already some of the weaknesses of vector-based search, and it is very powerful. It allows people to write just a sentence. They don't have to type in a very specific way, and you can find stuff based on meaning, even though they're using totally different words. It can be very conceptual and it can work, but there are weaknesses and you can have unexpected results like we saw here. One other technique I'll mention is something called HYDE, HYDE. It is hypothetical document embedding, I believe. This method basically takes a user's question and then generates a AI response to that question, like a plausible response, and then it does a search based on the plausible response instead of the question. And the reason this tends to improve the results is because the answer to that question tends to have a closer meaning and it tends to find closer matches than the question itself. Because if you think about it, a question and an answer can be semantically pretty different. If I ask, what is the best animal in the world, a answer about dogs being the best animal in the world would not be that semantically close to just saying animals, for example. So there's lots of scenarios where that can help, but it does also reduce the speed because you have to do like AI generation before you can actually do a search. Anyway, I'm not going to go down the rabbit hole too far. There's a lot of different things that you can do to improve your vector search. And one of the best methods is also to improve the way that you process information and put it in the database. So this method where I'm just taking random chunks in order is going to fail because this document says specifically everything under here is about people who have wielded Mjolnir. So if you knew that, then like if this whole snippet was returned, it would be able to respond very accurately. But because it's chunked like this, you have like little chunks randomly chosen by the amount of tokens, you're going to miss that context. So there's lots of things that you can do when processing the data to make that better. Okay, so second method I want to talk about is graph-based retrieval. So a graph database, let me just show you, looks like this in the visual form. All it is, nodes and relationships. So each of these circles is a node, and then each of these arrows is a relationship. This is often used for things like Facebook. You might have a node be a person, and then you have a relationship, a friendship to hundreds of thousands of people. And this is a performant way to do certain types of searches that have to do with like the relationship between different concepts to each other. A graph database is not frequently used compared to regular SQL databases, and there are definitely some downsides to them. And another thing to mention is you can kind of do this same thing with a certain database structure in SQL. So it's not like this is the only way to do it, but there are performance improvements for certain types of queries. And it can be one thing that's really nice about a graph database is that its schema is very flexible. So you can just kind of put in a lot of information without choosing a schema ahead of time. You don't have to have specific fields that are allowed, and it'll just accept all of that information. Now, what I'm using for this sample is a tool called Graffiti by Zep. So I'm just going to look it up for you. They have this open source tool that allows you to take information and update a graph database based on that information using an LLM. So if you have a user typing in information over time, you can learn about them and store that information in a graph database. Graffiti is really powerful. It has a lot of tools to retrieve that information using advanced search algorithms. And so I found that a lot of my results are a lot better just using this tool and trusting it to kind of make the right decisions for storing the data and retrieving it later. I had a developer work with me to set up this Falcor DB, which is one of the graph databases supported by Graffiti. And I'm going to be using that for this example. Okay, so I'm going to say in here who wields Mjolnir, and let's see what it says. So you can see that the tool I have connected is an MCP client. This is because I set it up with an MCP interface so that I could use the different tools available to me through MCP. Okay, this is a prompting issue. It did not even use the tool because it kind of knows the answer to this. And you can start to see that it has more information than my source information. I'm going to reset the chat session and says, who wields Mjolnir according to database memories. Let's just say that. That should trigger it to use the tool. I'm also using GPT-5 Mini, so it's not as good at reasoning and tool use. Okay, so here we see that we have a much more complete answer. Thor, Hela, Vision, Captain America. It doesn't mention Odin being the creator who would probably wield it, but that's all right. All right, let's take a look at what was output from Graffiti. So it's a little bit hard to read in this format, but you've got facts retrieved successfully. It retrieves a series of facts, and you can see a lot of backend information on the IDs of the different nodes and such. But you can see fact, Thor wielded Mjolnir as his signature weapon. So what this is doing is basically pulling in a bunch of information from the graph database. This is not the raw results of a query. This is kind of Graffiti's method of taking a graph database search and then combining it with other methods to show a series of facts as well as like the date that those facts became valid, so that if things change over time, it will be able to keep up with those changes and answer accurately over time. So anyway, this is a lot of facts that were returned. You can see it's quite a bit of information, maybe more than you would expect for a simple search like that, but it's able to process that information and answer pretty accurately. There's a lot that I could do with this as well, but all I did is basically dumped the entire document and created an episode out of it. It created this diagram, and then you can see stuff like, if I can find Mjolnir in here and double click on it, it will show me all of the nodes that are related to it. So you can see Captain, Vision, Hela, Odin, Thor, they're all related to it. And if you right click on this, you can see it does an embedding. So it's kind of a combination of vector search and graph database methods. And then you also have this summary that it does. And it does all of this using LLM processing. So when you input a document, it figures out what are the nodes and relationships to create. And then it figures out what the summary for each of these should be, what the relationship should be. So it's pretty cool technology. So the third method here is text-based search. Now this is the old school OG search. You search for a specific string of text in a database. It's not the best method for RAG, but there are certain times when it is appropriate. So for example, if you have users typing in someone's name, like maybe you have a community and you want people to be able to find other members in the community, so you build a search that allows them to find them by just typing in information like, I'm looking for someone who works in PR or whatever. Now, if that user types in something like someone's name, you might be surprised the responses that it'll get with vector search. Sometimes it'll say, well, I mean, these are obviously related because it's spelled the exact same. But like if you misspelled the name, oftentimes it won't find what you're looking for. So text-based or fuzzy search is often a superior method. A lot of it comes down to user expectations. People are used to normal plain text search and how that works. And I've had situations before where I set up a really fancy RAG-based search that's using vector database and should work really well, and people were not getting the results they expected because they expected to be able to just type in a keyword and get everything that mentions that exact keyword, but oftentimes the results did not prioritize perfect matches to that keyword. So this is one of the tools that you should have in your toolbox, because even though it's flawed and it only works if they spell it correctly and all of these other things, it is still useful for certain situations. Okay, so I'm going to type in who wields Mjolnir here. So what I've done is I've set up a Postgres tool, and all this does is allow someone to search this table, MCU snippets, and this, what I did is basically took the pages and processed and wrote a SQL query to get that information into a database. So I have a list of characters, and then I have a list of snippets, and those snippets are associated with the specific character that they mention. Not the best database design, but it works for this particular example. If I say who wields Mjolnir, it will search the database based on the specific mention of that word, and I prompted it to use the % sign so it could find anything like that. In this case, it's not going to work if it's not capitalized, and it doesn't work if, it's called a hammer. So there's lots of deficiencies with this method, but you can see it does return Thor and Hela because we found snippets with that specific word in there. So again, this is better for people's names, and I would generally take text-based search and add in fuzzy search. So you can have plugins in Supabase, or there's different methods that you can use to do fuzzy search, where if someone mistypes a letter or two, it will find similar ones. It's not using the meaning so much as just how close the words are together in spelling. And that can be really useful as well. And something that you can do is combine those methods together, as I'll get to in my fifth example. So just wanted to show you an example of RAG using plain text search, because it's something that people don't even consider as a possibility. Okay, so the fourth example here is one of the most exciting to me, which is taking a raw question and turning it into a SQL query and querying a database that way instead of using a vector database. So with this, you're relying on the fact that an AI agent and chatbots in general are really good at writing SQL queries. So if they understand the schema of your database, they can write a valid SQL query, I would know, 99% of the time accurately, and they can find information in a really structured way. So in the example I'm going to give, this is not the ideal scenario to be using a SQL query, but it is great for situations where you have structured data, not necessarily large paragraphs of information like I'm working with here, but structured data like relationships people have with each other, the number of users in an account, just like tables and rows of data in a SQL database. This is very appropriate for getting that information. And it answers things more accurately for certain types of questions. So I'm going to try Who Wields Mjolnir and see what it tries here. Okay, so for this type of question, the query that it writes is basically to search for this text. So it's basically doing a plain text search, just like the previous example. So this is an example where the question I'm asking is not really the best for a SQL query. So how about I ask something that's more appropriate for a SQL query, which is how many characters are there in the MCU universe? This is the type of question it might just answer from its knowledge base. Okay, great. So it's using the database, it's doing a select count from characters, which is the right query to use, and it answers accurately. Now, if I were to ask the same question in the vector database, for example, that question almost never have the right answer. I can basically guarantee it won't have the right answer because you're only going to return a few snippets to the user and it's not going to have a complete picture of the data. And the question, how many characters are there in the MCU universe, is not going to be similar to any of the information in that document. The only case where it would get the right answer is if there is a specific Q&A, like how many characters are there in the universe in the source material, and that is surfaced and that becomes a response. But if you don't have that type of question and answer format in there, then it's just going to find kind of irrelevant information and it's not going to know the answer. It'll probably, let's just try it out. But okay, so let's try out asking the same question in the vector database. And my guess is it's going to go off the number of characters in the source material that it responded with, or it might even say just, I don't know. We have this separate step that's processing it, which is probably going to muck up the results a little bit, but let's see what it says. Okay. Yeah, so this one is basically saying, I don't know. I don't have information. And the reason why is this is what gets responded to. So this is the most relevant chunk according to a vector database. As you can see, it has nothing to do with the question at hand. And that's not a problem with the vector database. That's just not the right type of question to ask a vector database. So it's a matter of understanding the right tool for the job. For like data analysis, where you need to answer accurate questions from what people are asking, SQL is going to be way, way better. An example of something that I've implemented with a SQL query is basically, I have this database of all of the different N8N workflows I've set up across dozens of different N8N instances, and I also have a list of all of the nodes in those workflows, and I have those stored as vector embeddings as well. I have a description of each node and workflow, AI generated, and I have an embedding of that description, so I can search for things with plain text, like I need a API call to the Lawmatics API, and I can find something like that. But if I want to ask it, for example, what is my most complex automation by number of nodes, I can't get that from a vector database, but I can from SQL, because it can do a search for the workflow with the most associated nodes. Or if I want to find every workflow that I have for a specific client, I can say, here's my client's URL, instance URL, what are all the workflows that I have for this one, and it can do a SQL query and answer that question. So I would say enumeration type questions where you're trying to ask a number, like how many of something, or questions where you need to get all of the relevant results back, or where there is very specific filters that you could use to get to that information, that's where a SQL-based query is going to be the best. Now, one thing I will say is you have to implement it in a secure way, because if you build an AI agent that is just allowed to execute any SQL query on your database, then any user could just prompt it to delete everything or to reveal sensitive information. So you need certain processing steps in between the AI agent and the actual query being run. And that's a whole other topic that you could get into. But as a concept, that is a very powerful way to do it. Okay, so the fifth method is hybrid. It's really just taking all of the other methods and allowing an AI agent to choose between them. So I'm going to ask who wields Mjolnir, and let's see what it does. So what I've done is I've attached the SQL query option, the graph database option, and the vector store option. And I have given it some loose prompting saying like you can use multiple of the tools and given it examples of which tool to use in which situation. But I could do a lot more to guide it because right now it's just doing a bunch of different SQL queries, which is interesting. And you can see that it seems to be trying to pull specific answers over here. But somehow it has managed to answer accurately with the 5. I'm not entirely sure how it did that. Oh, okay. So this was with better prompting. It was using hammer as well, or lift. So it was actually using alternate keywords and doing a text-based search in the SQL database. And that's the difference that prompting can make, because I told it specifically you can use the same tool multiple times with different phrasing. It's not great that it only used the SQL tool, but that's something that can be fixed with more prompting or a better tool description or whatever. So it is interesting that with this method and better prompting, the SQL query was able to respond perfectly accurately, at least according to this source material. Now, if I were to ask how many characters are there in the MCU universe according to our data, this is also a good SQL query type situation. 13 characters. Okay, I'm going to try a question that is more appropriate for a vector type search or graph database search and see what it does. What can you tell me about Doctor Strange? Interesting. We definitely need to update the prompting to make it more likely to use these other options. It seems like my guess is, I mean, to be fair, I'm using GPT-5 mini. So I'm going to try switching to a higher reasoning model. But my guess is that AI tends to try more technical things. It has a more technical outlook. And my guess is it thinks, oh, well, why would I use these other tools when I have raw SQL access? That's going to be better than anything else. So I'm curious what it does with a different model, but you definitely would need to use prompting to be like, hey, don't just use the SQL query, use these other methods as well. So GPT-5 is also using SQL query. Okay, so I updated the prompting a little bit and basically just said, don't just use the SQL query tool, and let's see what it does now. You want to give it the guidelines on what tools to use in what situations so that it can have some sense of autonomy and adapting to the situation, but also is not going to just default to whatever it feels most comfortable with. And now we have a better response because I've got, it searched the SQL database, but it also did the graph database search, and it has a lot more results than if it had just used one of those tools. So when accuracy is important, or when you want to find kind of a needle in a haystack type of thing, it's really good to have lots of different tools available. I think if from all of the ones that I've covered here, if you implement a really good vector or graph-based search and then also have a SQL type search available, those two in combination are really powerful and will catch 99% of the instances. Fuzzy text search is also another great option to have as a backup because a raw SQL query won't do a fuzzy search. But if you combine all of those together, that's some of the best options for searching available to you, and you can use different methods to make the data better. But something I really want you to understand about the process of building an AI agent that has RAG capabilities is that your data matters and the structure of your data really matters. You can use all of the best techniques in the world, but if you don't process your data in a useful way to make it more structured or to summarize it in ways that retain context, you're going to notice that the answers are not very accurate or they're missing key context. So returning to an example from earlier, if you have something like this, people who have wielded Mjolnir, and then you have all of these different paragraphs just kind of going into the database by themselves, you're not going to have the rich context that this is actually listing someone who can wield it. So if, let's say this was just a list of names without any further context, and it was separated from this piece of context, you would have no idea what that list of names even represents. And so smart document processing is important. One of the things I want to make a video about is how you can use cheaper models like Gemini 2.5 Flash to take massive documents, within the context window limit, of course, and output smart snippets from it instead of just using the regular chunking approach that we use here, where you're just taking a certain amount of characters or tokens and splitting based on that. You can do a smart split that basically includes summaries of how this snippet fits into the larger document. There's a lot of processing that you can do ahead of time to make your data that much cleaner. I really hope this video has been useful for you. If you're interested in creating an application that uses RAG to create powerful AI agents with real-world knowledge, then contact our team, because we're building that for many of our top clients right now. But also, if you're interested in the topic of AI agents in general, I have a video about how you can make AI agents learn over time with the ability to add rules and information to their system prompt over time, and I think that would be really relevant to you. That video is coming up next and linked in the description as well. Thanks so much for watching, and if you're interested in this topic, I will be releasing more information about AI agents and how you can guide their behavior and make them more and more useful. Thank you.